Okay, I wanted to do a very quick review on stoichiometry for those of you who are still having questions over it. So I'm going to go ahead and get started. So stoichiometry, official definition is the process of using a chemical equation. As you can see right over here, I have a chemical equation, C3H8 plus O2 yields CO2 plus H2O. So the process of using a chemical equation to calculate relative masses of reactants and products in a chemical reaction. So basically this is the deal. Stoichiometry is you are given the mass or the moles of a certain substance, whether it is on the reactant side or the product side, and you have to calculate, we call it the theoretical yield, we have to calculate using stoichiometry how much of something will be produced or how much of something is needed. That's the whole idea behind it. It is based off of what we call mole ratios. So mole ratios are just the coefficients that we put in front of the formulas to balance the equation. So to balance this, I would have to have a 3 here, a 4 here, and a 5 here. So my mole ratios, now we don't ever write it, but you have to imagine there's a 1 here. So my mole ratios are going to link one substance to another. So in this equation, I need 1 mole of propane to every 5 moles of oxygen. I need 5 moles of oxygen to produce 3 moles of carbon dioxide. I need 5 moles of oxygen to produce 4 moles of water. So we can do several mole ratios. We could say I have a 1:5 ratio, I have a 5:1 ratio, I have a 5:3 ratio, I have a 3:5 ratio, I have a 5:4 ratio, I have a 4:5. I have a 3:4 ratio here and a 4:3 here. So you can come up with many combinations of mole ratios, and we actually would put these in the form of a fraction. So if I wanted to know what my ratio was of propane to oxygen, I would say 1 mole of C3H8. Ugh, that's terrible. Let's try that again. 1 mole of C3H8 to 5 moles of O2. So if I needed to produce 3 moles of carbon dioxide and 4 moles of water, I would have to have 1 mole of propane to 5 moles of oxygen. So I can take these mole ratios and put them in the form of a fraction, and we're going to use this, okay, these mole ratios to change from one substance to another. That's my only link. From propane to water is my 1:4 ratio. Or my oxygen to water is my 5:4 ratio. Each of those ratios can be put into a fraction, which we can use in a dimensional analysis problem. Again, we are essentially, okay, in problems, I might be given like the mass of oxygen, and then I need to find how many moles of water is produced. That's called stoichiometry. Or I might be given 2 moles of oxygen, and I need to find out how many grams of propane is needed for the reaction to happen. So that is what stoichiometry is. You'll be given amount of a substance, and you're going to have to figure out how much of something else is produced, or maybe how much of something is needed. Several type of problems. You could have a mole to mole problem, you could have a mole to mass problem, you could have a mass to mole, or the long ones are mass to mass. Okay? It's considered stoichiometry. It's like we're predicting theoretically how much of something is needed, okay, or how much of something is produced. We call our answers the theoretical yield. Now, if we are to do the reaction in the lab, whether we get that perfect amount or not all depends on our situation in the lab, how good our equipment is, as long as we're not doing any calculation errors. Our experimental yield should equal our theoretical yield. So when we are calculating, okay, the answer to a stoichiometry problem, that's our theoretical yield. Like theoretically, if everything was perfect, this is how much is going to be produced. Okay, so just a few things. You always have to start with a balanced chemical equation. If you don't start with the balanced chemical equation, your mole ratios are going to be off. Okay? The next thing you have to do is you have to figure out what are you given and what are you converting to, or what are we solving for? Are we given moles and have to find mass? Are we given mass and have to find moles? Are we given mass and have to find mass? Okay, you have to figure out what you're given and then what you're trying to solve for. And we're going to use dimensional analysis to solve these problems. So let's do a few here. So it says calculate the mass of oxygen required, okay? So I'm going to put question mark up here. Calculate the mass of oxygen required to react exactly with 189.67 grams of propane in this reaction. Okay, so we are given 189.67 grams of propane, and we want to figure out how many grams of oxygen we need for the reaction. So the first thing is we have to balance it, and we already did. We said 4, 3, and 5. So I always start with what I'm given. 189.67 grams of C3H8. Now, my connection between mass and moles, because the only way I can switch from moles of propane to moles of oxygen is I have to convert my given mass into moles. Then I'm going to come up and use my mole ratios. So I'm going to do that by using the molar mass of propane. So I'd have to go to my periodic table. I have 8 atoms of hydrogen, each at 1.01. I have 3 atoms of carbon at 12.01. So this is 8.08. I can go to my calculator. 3 times 12.01 is equal to 36.03. Now I'm going to add those together. 8.08 plus 36.03. So the molar mass of propane is 44.01 grams per mole. So now C3H8, C3H8. So now I can get rid of grams and I'm sitting at moles. Now I need to switch. I need to move from moles of propane to moles of oxygen. So I'm going to pretend there's a 1 right here. 1 mole of propane equals 5 moles of O2. So I'm using my mole ratio right up here in the middle of my equation so I can switch substances. So now my moles of propane are gone and I'm sitting at moles of oxygen. If I want to get to mass of oxygen, I use the molar mass of this molecule. So I know I have 2 atoms of oxygen, each at 16.00 is 32.00. So the molar mass of O2 is 32. Let's try that again. I'm going to say 1 mole of O2, I just calculated it, is 32.00 grams of O2. Moles are gone. Now, I myself, see, I like to set up the problem, and I like to do all the multiplication at one time. So I'm going to say 189.7 times 5 times 32 equals, the only thing I have on the bottom is this guy. Everything else is 1. So now I'm going to divide it by 44.01. Try that again. 189.67 times 5 times 32 divided by 44.01 is going to give me 689.55 grams of O2. So if I start with 189.67 grams of propane, I have to combine it with 689.55 grams of oxygen. That is stoichiometry. Anytime I want to get from grams to moles, I use the molar mass. Anytime I want to switch substances, I have to come up here and use my coefficients. And again, if I need to go from moles to grams, I have to use the molar mass. Let's do another one. Ammonia is used in huge quantities as a fertilizer. It is manufactured by combining nitrogen and hydrogen according to the following equation. Calculate the mass of ammonia that can be made from 2.63 grams of hydrogen. So I am given 2.63 grams of hydrogen, and I need to figure out how much ammonia can be made. So my first step is balancing the equation. So I'm going to put a 2 right here. That gives me 2 nitrogen and 2 nitrogen. 2 times 3 gives me 6 hydrogen, so I'm going to have to put a 3 here. So it says calculate the mass of ammonia that can be made from 2.63 grams of hydrogen. So this is going to be a mass to mass problem. So I'm going to start with what I'm given. I'm going to change colors here. Or not. Okay, 2.63 grams of hydrogen. Now, in order to go from grams to moles, I'm going to use the molar mass. So I'm going to go to my periodic table. I have 2 hydrogen atoms, each with a molar mass of 1.01. So I'm going to multiply that together. So the molar mass of my 2 hydrogen atoms, 2.02 grams of H2, is equal to 1 mole of H2. Again, that fraction represents the molar mass of H2. If I have 1 mole of H2, this is the mass in grams I have. Those cancel out. I'm going to come up to my equation, and I'm going to use my mole ratio. I have a 3:2 ratio. I'm going to say 3 moles of H2 is equal to 2 moles of NH3. I just switched substances. So my moles of hydrogen are gone, and I'm sitting at moles of NH3. But I have to get to the mass of NH3. So I'm going to use the molar mass. 1 mole of NH3 is equal to its mass in grams. So I have to calculate the molar mass of NH3. So nitrogen has a molar mass of 14.01. Hydrogen, I have 3 of them, 1.01 each, to give me 3.03. Now I'm going to add them together to give me the molar mass of NH3. 14.01 plus 3.03 is equal to 17.04 grams of NH3. Moles of NH3 are going to cancel out. Again, I'm going to put a 1 right here. I'm going to multiply everything straight across, and then I'm going to divide by everything on the bottom. But when I have more than one thing on the bottom in my calculator, I like to put them in parentheses. So this is how I'm going to do it. 2.63 times 2 times 17.04 equals, then I'm going to do divide, then I'm going to put open parentheses, 2.02 times 3, close parentheses, equals, so my answer is going to be 14.79 grams of NH3. Okay, hopefully that helps a little bit. Hope you guys have a great day.